What's up, Curious Readers? I'm Dave from Dave's Book Summaries, and today will be a little different video. Instead of doing a book review, I will be doing a project review on a project done by me. I did this project for my school engineering fair, and this project earned me one of the 3 honorable mention awards. So without further delay, let's get into the video. So, I will be giving a little detailed info on how the project was done using all the required sections that we had to put in for the school project's presentation slides. So, my project was a Raspberry Pi Smart Mirror, which was made using a Raspberry Pi. So first, let's understand the Raspberry Pi before going into detail specifically about the project. The Raspberry Pi is a series of small single-board computers, but it isn't like the regular computer you use in everyday life. It is a mini version of the inside of that computer. All the basic components are on a single circuit board. The Raspberry Pi has many features like the USB ports, Ethernet ports, audio jack, HDMI ports, and the GPIO ports. Let's learn what all of these do. The GPIOs are used to connect extra components like the LEDs and buttons. There is also an SD card slot, which is where the SD card is inserted. This card has all the files for the operating system that you are going to use in the Raspberry Pi. The micro USB power connector is to connect the power supply to the Raspberry Pi. You can make this a desktop by connecting a monitor, mouse, and a keyboard to the Raspberry Pi and then turn it on. Once the OS is installed, there you have it, a mini computer of your own. You can search, edit text, program, play games, and a lot more things. So now that we have a brief info on the Raspberry Pi, we can move on to the actual project that I did, the RPi Smart Mirror. First up in any project is the engineering goal. My goal for this project is to display basic information such as day, date, time, weather, and some news feed on a mirror. This allows you to look at the information while getting ready in the morning and get caught up on your day. Now, you need to know all the materials you will be using with exact measurement for size and amount of how many you will need. Here is my list. A Raspberry Pi, 1 low-profile monitor, wood pieces of 2 kinds, wood glue, HDMI cable, a see-through mirror, saw, gloves, hammer, and nails. The exact sizes are on the screen. Now, no project is possible without a specific procedure. So here is my procedure. First, we cut the bigger wood pieces at 45 degrees angles from the side. The length can also be adjusted, and when you are happy with the length, you can make the 45-degree cut. Since the mirror is going to be portrait view, the long pieces are going to be on the sides. Then you cut the smaller wood pieces. These smaller pieces will be the top and bottom of the frame. These ones will also be cut at 45-degree angles. And make sure that you cut the 45-degree angles in a way that you are able to get the sticks into proper position so that there is no gaps in the middle of the wood pieces. Third, you use wood glue and the nails to attach the pieces perpendicular to each other, creating a rectangle frame. Then you attach the mirror after cutting it to the perfect size so that it fits inside the frame without any bends or curves. Next, you attach the monitor onto the mirror from behind the frame. Make sure you also install something on the behind of the frame that holds the monitor in position so that it doesn't fall out of place. Now you can start the coding of the Raspberry Pi. You use many files and you download them, and the link for those will be in the description below. Now you connect the Raspberry Pi to the monitor using the HDMI cable. You turn the monitor on, and then you check if the code is working properly by double checking the info with your phone. If you find that anything is not working, you check your code and debug it. Also, make sure that your monitor is on and is connected properly to your Raspberry Pi with the HDMI cable. So another thing we need to be careful of in the procedure is that if you want to add the weather information to your mirror, you need to go inside the code and make some big changes to it. because the section that actually displays the weather in the code will be commented. That means it won't work. So you have to uncomment that and add your own location and the API token from a specific website, which you will get information for in the description, and I will speak that information later on in the video. I have created two graphs that explain more on what I did with the code and how the thing works. So this one, the first one that you are seeing right now, is a graph based more on definitions. Firstly, let's look at the big main definition on the top. A client is something that converts data stored in computer language into meaningful words and images, also known as user interfaces humans understand easily. This just means that when something is called, then the data stored in computer language just converts into the pictures and images that humans can understand easily. So the first one is that the image is displayed based on some conditions. The code is written in a way that if the temperature is above some degrees, then it would say hot, otherwise it will be cold. And then based on that condition, if it's true, then it would take the data for hot and show the user interface with the picture of sunny or hot or whatever it is. The second graph is behind the scenes of how the weather info got to the mirror. Firstly, let's understand that I used a website called openweathermap.org. The link for this will also be in the description below. So I'll be guessing the behind the scenes of what this website actually does in a pretty predictable pattern. First, the website has weather sensors every few miles placed, and the weather sensors report any change in temperature when it happens. Then, a service sends this to a server using the post command. Then, simple text format is posted for immediate readings on the website, and it's stored inside the database so that they know if the change is big or minor. Then a new server would use the get command to intake that info after they create an account on that website. So now let's talk about the conclusion, but don't worry, this is not the last thing that I'm going to be talking about. There are a couple other parts after the conclusion, so stay tuned. But first, let's finish the conclusion. The conclusion is, the information of time, day, date, weather, and newsfeed is successfully being displayed on the monitor when the monitor is attached to the mirror. The user is able to see the information clearly and also see him/herself. To check if the information is correct, the time, day, date, and weather was double-checked with the weather app clock on the iPhone repeatedly. The goal was to have everything displaying properly in the proper locations on the mirror, which was achieved, but the mirror can't be left out on the whole time because the Raspberry Pi isn't a computer so strong that it can be left on 24/7. To achieve this thing, the mirror needs to be connected with a computer that is able to stay on 24/7 without overheating or malfunctioning. The user can also pick out the outfit based on the weather that the mirror is showing them. Now let's do the error analysis. There were not many errors in the whole thing, but something that would have helped in the building of the frame is not leaving the wood glue even in small lumps while attaching, because the glue got to a little on the outside, which caused a little visual defects. Using oil paint was also not a great idea either, because it took a few days for the whole thing to dry out properly before the designs could be attached. Another thing that messed up a little was using the see-through mirror sheet. We should not use this sheet because it's automatically bent since it's so thin and flexible. That is why you should use hard actual mirrors instead of sheets. Now let's talk about future applications of this project. Firstly, one of them is fixing the errors, which is removing the mirror film and attaching a big solid mirror. Next, the mirror can be personalized to the user's interest in many ways. This helps benefit the user with a more personalized mirror. This can be achieved by adding the user's Google Calendar on the mirror instead of holidays, And the user should also have an option of the weather being shown in Fahrenheit or Celsius. An AI can also be added which responds only to your voice like Alexa or Siri. Connecting to home appliances and running them from the mirror is also possible. Now let's talk about a little future research that will be possible on this Raspberry Pi Smart Mirror topic. Learning more of each language will help in adding the future applications. By language, I mean the computer programming languages like Linux, JavaScript, HTML, CSS, etc. To learn more about the languages, researching and practicing with other projects is also important. There's also many other projects with the Raspberry Pi to search about and doing them. And after adding to the AI on the mirror, Face ID comes with biometrics code and algorithms, which is also a whole new branch to explore and learn about. Now, before we leave, let's look at some pictures from my project. Alright guys, thank you so much for watching this video and spending time to look at my Raspberry Pi project. And make sure you also buy a Raspberry Pi because it's very cheap, and you should also try some of these projects with the easier one. And then you can also do the one that I have done today. Also, a very Merry Christmas to you guys, and also a very Happy New Year and peace. Thank you.